Hello everyone, welcome to this class. In this class, we're going to deal with union and intersection of sets. First, let's start. Union of two or more sets is the set of all elements that are at least one of each set. I will explain this when we start solving our example. What it's trying to say is that if you have a set, this is set P and set Q. The union is another set that has everything that is in P and also everything that is in Q. The symbol is this long U, not just U, a long one. The intersection of two or more sets is a set of elements common to all sets. So if I'm to explain it, if you have a set P and a set Q, the intersection is what does this have and this also have? Only, exclusive to only what both of them have in common. So let's solve example. Excuse me. Example 6. Write down the union and intersection of the following pair of sets. Represent the result in Venn diagram. So we have set P. The union of P, let me use the word U as will be what this have and this have, a set that have both the members of P and Q. So I will just say we have Monday, comma, we have Friday, and we have Saturday. Mind you, don't need to repeat the members of the set, and we have Sunday. So if you look at this, Monday is here, Sunday is also here. Everything we have here is here. Friday is here, Saturday is here, Sunday is here. So this is the union. While for the intersection, represented as this, we only check for what this and this have in common. So the only thing they have in common is Sunday. So for the intersection, we only have what? Sunday. Very simple. So for Venn diagram, we all know that Venn diagram, I will draw a circle for P. Let me write it here, Venn diagram. I also draw another circle. Meanwhile, we already know from our example there is an intersection, so I will intersect the two circles. I'll call this circle P. I'll call this circle Q. Remember what we did in our previous class? First solve for what they have in common before you write for the rest, so you don't repeat anything. So what they have in common is Sunday. So let me write Sunday here. There's an error. This is Sunday. So then he also have Friday and Saturday. So I'll write Friday. I'll write Saturday. So if you check the circle for P, it has all the members of P. Remember what I told you in the Venn diagram, the circle you use to represent the set must have everything without repeating it. So that's why we usually write the intersection first before we write out the remaining ones. But if you not write it, you might end up writing it and also write it will not be repeated. So for Q, we have Sunday inside here. The only thing remaining there now is Monday. So if you check the circle for Q, we have Sunday and Monday, which is what we have in the set of Q. Let's go to the next example. So in this example, we have X, set X as R-E-L-A, and set Y as T-I-O-N. So first, we have been told to find the union. For the union, we have something like this. It must contain everything. So let me tell you the easiest way to go about it. Write out one set. While writing out the other set, write out the second set without repeating. Let's go. R, E, L, and A. Right? Complete. Then we'll start writing for the second one. T. Do you have T here? No, so we can put it. I. Do you have I here? No, so we can put it. O. Do you have O here? No, we can put it. N. Do you have N here? No, we can put it. So this is the easiest way. So if you want to write for the other set, but sometimes union set will be more than 2. If you notice that you've written the thing already, don't repeat it. Just move to the next element. The idea is to make sure that all the elements in the union set is in all the subsets. So let's go for the intersection. If you check, when we are checking this, notice that these two sets does not have anything in common. So the intersection will just be a null or empty set. This is the symbol for null set. So for the Venn diagram, so we're going to have something like a circle for X. This is for X. Another circle for Y. This is for y. Since we know that we don't have anything in common, that's why you see that I didn't need to intersect the two circles. This kind of sets are called mutually exclusive sets that don't intersect each other. So we have R. We start writing everything. E, L, and E. For the other one, we have T, I, O, and N. Very simple. So let's solve for exercise 5E. In this exercise, we are given universal set. Whenever you see this kind of symbol, you know you mean the universal set. And universal set is simply a set that contains all the subsets. If you check this XYZ, everything in this XYZ is also excuse me, is also in this excuse me, universal set. So we have set X, set Y, and set Z. So let's start solving for some special cases. You have E to look for X union Y. Remember the trick I told you when we were doing this? Simply write out the X. We have A, B, C, and D. So for Y, we'll now start going C. C is already here, so we don't need to write it. D is already here, so we don't need to write it. E is not here, so we'll have E. This is the answer. So the next one we are going to solve for B is X union Z. Remember what I said? Write out X first. A, B, C, and D. Then go to Z. B is here. D is here. Only F is not there. So now write out the F. This is the answer. Hope you are following up. It's very, very simple. Go to the next one. We have Y union Z. So in that case, just write out your Y, C, D, and E. So for Z, B, write out B. B is not here already. D is already here. F is not here, so write out F. Mind you, the rearrangement of set does not affect it. If we are to make this in alphabetical, it's supposed to be B, C, D, E, and F. This B is supposed to be here. So, but the arrangement of set does not affect it. So, if you get this, it's still correct. Or you can just rewrite it so it will be more organized. C, T, E, and F. So let's go to the next one. D. You have X union Y. I think we've done X union Y already. So let me just leave this and do X intersection Y. So let's cancel this out. So what does X and Y has in common? They have this A, B, C. They have D in common, and they also have C in common. So C and D, that's number D. C and what? D. So simply write C and D. Then E. Number E, we have X intersection Z. So what does X and Z has in common? You check, X has B, Z has B. X has D, Z has D. So they have P and D in common. Number F, we have Y intersection Z. So what does Y and Z have in common? If you look at it, they only have D in common. The rest are different. So just write your D. Number E, F, G. Number G, we have X union set. Anything that is coming union with union set, what will be the answer? The answer is obviously the union set. But what union does is that it includes everything that the two sets have in common. And we all know that union set has all the subsets. So we know that once the union set like A, B, C, D, then E, F. So the answer is just the same union set. That's the answer. Which if you can decide to write it out, this is the answer up here. So anything that is union, any subset that you are going to solve for the union with the union set, the answer is still the same union set. So let's solve it out here so that you understand what I mean. Let's say we have to do something like, let me write out X first. A, B, C, D. I think that's what X is. The union set A is already here, B is already here, C is already here, D is already here. E, now write that E and F. So by the time you check, you notice that this is also equal to this union set. So any set that is, you are looking for the union together with union set, the answer, you don't need to solve for it, just know that the answer is the what? Union set. The same way, any set that you look for the intersection with, although when we go to the intersection side, we'll talk about that. Let's go to the next example. So where do we stop? We are in the next page, so I have to write all the sets. These are our union set A, B, C, D, E, F, our X, A, B, C, D, our Y, C, D, E, and our Z, B, D, F. So we stopped at G. The next we are going to do is H. H is a union set, union Y. Remember what I said earlier, we don't need to solve for it, just know that the answer is the same as union set, because union set contains everything that Y has. The next we're going to solve for is I. I is Z union set. Z union set, or would I say universal set? I think the right word is universal set. I've been using union set since, so correct that. The answer is still the word universal set, because universal set contains everything that Z has. In this case, universal set contains everything that Y has, which you can see up here. So, and we all know that union of a set is just that set that has everything that the two sets we are looking for has. So the next IJ, the next one is J. J is universal set intersection Y. Are we together? Or let's say universal set intersection X. So whenever you have a universal set intersecting a set, and that's a subset, just know that the answer is just a subset. You can just simply say the answer is what? X. What do we mean? X means, what's X? A, B, C, D, right? Now we are going to look for the intersection of universal set and X, which is, what does X and universal set have in common? We all know that everything that X has, universal set has it, but it's not everything that universal set has that X has. So you have A, B, C, D. Let's assume we are solving it. I'll just solve for one. The rest I'll just move straight to the answer. We have A, B. They have A in common. They have B in common. They have C in common. They have D in common. E and F, they don't have it in common, so you can't include it here. So if you look at this A, B, C, D, it's the same as X. So the answer is just X. Are we together? J, K. We go to number K. We have Y intersecting universal set. In this case, I don't need to solve, just so that the answer is what? Y, which is the same as all the sets here. If you solve it manually, you see that you're still getting the same answer. L. Number L, we have universal set intersecting Z. The answer is what? Z. You don't need to solve for it. We've already explained it here. M. Go to number M. We have X union X, like a set union itself. What do you think will be the answer? The answer will still be the same set, to be X. I'll stop jumping line. So look at it. This is X. You are being told to look for the union of X against itself. Simply, it's what does X have and the same X has again. It's like saying, what's the union of, let me solve it. It's like saying, what's the union of, this is X, which is equal to A, B, C, and D. And you're being told to look for the union of this and the same X again, which is equal to A, B, C, and D. By the time you start solving, you'll be like, what does this have that this have? A. The answer is, they have A, they have B, they have C, and they have D. Though this calculation does not really, it doesn't really make sense, but we have to solve it to explain this better. So look at it. So any set with union that you're looking for the union of a set and itself is still the same set. The same thing applies to intersection. Because let's solve for the intersection of X and X. What does the two of them have in common? They still have the same thing in common, because it's still the same set you are also solving for. Are we together? So let's go to N. Y union Y. So your answer is Y. I don't need to solve for this. I've already explained MN. So we'll go to O. We have Z union empty set. When you are to go to Z union empty set, your answer is still the same, Z. Explanation. You have Z here, and you are solving for the union of what's an empty set? An empty set is like this is Z, and you have Z. Let's say Z is B, D, and F, and you have an empty set, which is a set that has nothing inside. So by the time you check for what they have in common, look at nothing is here. So simply just know that the union is just what you have in Z, because union is what both sets have in common. Here nothing is here, but this one has this value. So your answer is what? Z. So the next one is P. P is X union Y union Z. Now, you have been told to look for the union of X, Y, and Z. Though normally in board maths, we are supposed to solve for the bracket first before we now start solving for outside bracket. So if we are to solve for this, we will simply get what's the union of Y and Z. Then whatever you get from union of Y and Z, you now come and solve for union of the value and X. So let's go for what's the union of Y and Z. Let's go for Y union Z, which should give us, this is Y and this is Z. So you have C, D, and E. While Z is B. B is not here, so we write B. D is already, although we've done this in the previous side, D is already repeated, so we don't need to write it. Then F, right? So we're now going to do this and the union of what? X. So we now have X union Y union Z, right? So if you have to go by that, we write out X, A, B, C, D. So now start. C is already here, D is already here, E is not here, so write it. B is already here, F is not here, so write it. So this is our final answer. By the time you check this final answer, what do you observe? You observe that this is the same as our union set. Because when you are told to look for the union of all the subset, and we all know that all the subset is what makes up the union set, it's also logical to say that the union of all the subset is the same as the what? Universal set. So this is equal to universal set. So when the union of all the subset is the same as saying you are looking for the what? Universal set. So we are just in P. Next is Q. If you check for Q, we are being told to look for X union Y union Z. Now look at this. This and this are the same. There's what we call commutativeness. Irrespective of the fact that we remove the bracket from Y and Z and put it in X and Y, we are still doing the same thing. We are still looking for the union of all the subsets, which will still give us our what? Universal set. Are we together? So the next thing we are going to do solve for is this will be equal to universal set. Next we're going to solve for is R. R is X intersection Y intersection Z. So what we are going to do now, we are going to solve for the bracket first. So we are going to solve for Y intersection Z. This we've done before. What does Y and Z have in common? I think it's D. Yeah, only D. So the answer is what? D. So we now look for X intersection, that Y intersection Z. And what does D and X have in common? This is X. It's only D that also have in common. So the answer is also what? D. Hope you are following. The same way, we go to number S, R, S, yeah, number S. We have X intersection y, or in bracket intersection z. Also, commutativeness also relates here. Whether we are putting the bracket here or putting the bracket here, it's commutative. Wherever you put the bracket, even if you want put x intersection z before intersection y, it will still be commutative. So we don't need to solve for this. The answer is also whatever we got here, D, which you can also solve it for yourself. You can first look for x intersection y and then do the intersection of whatever you got with intersection of z, and you see that you are still getting your what? D. Are we together? So let's go to the next one. Next one, QRST. Hope we are digesting it. Very easy. So all we need to do is just calm down, understand intersection and union set, and pick it one after the other. And if you have a bracket, solve for the bracket first. So let's go to number T. Number T says x intersection y union z. So first, let's solve for the one in the bracket. I think this y union z will solve it here, which is this. So I can just say, okay, this is y union z is equal to what we got here. Where is it? C, D, E, P, and F. So now we have to look for now x intersection this y union z. So this is our x. What does x and this have in common? So let's go there. This is A. It does not have A. C. It has B in common. So write out the B. Number what also number T. Write out the B. It has C in common. Write out the C. And it also has D in common. Write out the D. So this is our answer for number T. So the next, we're in another page, so I have to rewrite everything out again for us to see it visibly. The next we're going to solve for is U. And U is are we together? So our U will be x intersection y union z. So x intersection y is, let's solve for x intersection y, would give us, what does x and y has in common? What do they have in common? This is x and this is y. So I have C, D in common. So C and D. So x intersection y union z. So what does this and z has in common? Sorry, what's the union of this and this? So we have B, C, D, and F. Very, very simple. Let's go to number V. We have x union y intersection z. So let's go for what is y intersection z. So what does these two have in common? We have D in common, I think. Only D. We only have D in common. Yep. So x now union this y intersection z. So what is our x? Our x is A, B, C, D. So you're having something like A, B, C, D. So when you come to the other, D is already here, so you don't need to repeat it. So you can notice that this also repeating our x, so you can also say that this is equal to x. Let's go to W. For our W, we have x intersection y union z. So our x intersection y, we've already solved for it here, which is our CD. So we have C and D. Then union Z, we now have X intersection Y union Z will be equal to C and D union of this. So we'll now start writing out. We have B, we have C, we have D. D is here and D is here, so we'll just repeat it once. We have F. Are we together? That's number W. Are we together? So this is what we get. But if you look at it, I just realized that I repeated this question. This is what we solved for here. So the mistake I made was this was supposed to be X union Y intersection Z. So we've already, I think let's correct that. We'll just go for W have X union Y intersection Z. And let me just put all of them in bracket. So you have X union Y will be equal to, what does X and Y has in common? We've done this before. A, B, C, D. C, D is already there. E, we just write the E. This is X union Y. Then intersections of Z. So X union Y intersecting Z will give you, what does this and this have in common? It's only B and D. You check it very well. So your answer is B and D. So number X, we have X union Y. This is just X intersection Y union X union Z. So let's solve for X intersection Y is what? X intersection Y will give us, I think we've done this here. This is BCD, right? No, look at it. X intersection Y is CD. C and D. Then X, this is intersection. Please forgive my mistake. Then X intersection Z. Have we done it before? No. So let's solve for it. What does X and Z have in common? We've done it previous example. X, A, B, C, D. B, D, B, D, B, D. So they have B, D in common. So X intersection Z is what? E and D. So now we are not to look for the union of these two. So it will now be X intersection Y union X intersection Z. So we simply have B, C, and D. This is our answer. See how I solve it? Very simple. Just solve for those in bracket first before you solve for the ones outside bracket. Let's go for Y. Number Y. We have X union Y intersection X union Z. So X union Y is equal to, look at our X union Y, we've done it before. A, B is it, C, D, and E. Then X union Z, this is the other bracket. I don't know if I've done X union Z here. I don't think so. So let's solve for it. X union Z is, look, write out all the X first. A, B, C, and D. Just write out of all the X. Then B is already, I don't need to repeat it. D is already, I don't need to repeat it. Only F is out. So write F. So we have to look for the intersection of X union Y intersecting X union Z. So what does this and this have in common? So if we intersect, you have A, B, C, D. Then E and F are not common, so this is what we have. But if you check for this, you know that this is the same thing as X. So you can also say that the answer is X. Though when we start doing set notation, you understand how it makes more sense that S union Y and X union Z will definitely give you X, because it makes more sense that the union of S must contain everything that X has. The same thing, the union of Z must contain everything. S and Z must contain everything that X have. So by the time you do for the intersection, this and this must definitely come out, depending on if there is any extra thing that will be added. But in this case, no other extra thing. But that's not the scope of this class. So this is the last example we are doing for this class. If you have any question, do well to drop it comment section. Thank you.